Hello auditors, my name is Isheng. Today I'm going to teach you guys how to solve Ethernaut's Force challenge using Brownie Python. I'm also going to elaborate how this particular challenge is actually exploited in the real world. Let's begin. Okay auditors, we are at Open Zeppelin Force challenge. So this Ethernaut challenge, you can see that over here we have this force contract, and in order to complete this challenge we have to ensure that the contract of balance will be more than 0. So over here you can actually just create your own directory, then run Brownie init, which I have already did. So over here this is my directory, and you can see that this is my brownie config YAML file. So what this is that when you run your brownie script or brownie Python script, brownie will actually check this configuration first and then run the brownie Python script. So basically this is your dependencies and your remapping. Actually this is quite redundant for this challenge. And over here we got our .env, which tells Brownie to get environment variable at our environment file, and then get our private key at our environment file. So this is my private key and this is my Infura node API key. So why do we need Infura API key? Is because we are playing in Gorally testnet, and since we are playing with Gorally testnet, Infura is the node provider, and hence we need this API key to interact with our contracts in the Gorally testnet. So over here, this is the contract. You can see that there isn't any functions, any fallback function, as well as the receive function. So in order to complete this challenge, we can use the self-destruct solidity function. So I'm gonna explain this contract. So this is an attack force contract, and we can create a state variable of the force type as state variable, and then we have the constructor that basically initializes our vulnerable contract, which is false, and then we can call this false function. So this particular false function is payable. The reason behind this is that in order to solve this challenge, we have to send ether to this contract and then self-destruct this contract and send the remaining contract balance to our target, which is this solidity contract, this contract force. So you can see that over here, this is my function, make it payable, and this is the address of the target, and send the remaining balance of this particular contract into our false contract. So over here, this is how we're gonna exploit it. We have our contract instance, our player address, then we deploy our attacker contract, and then we call the false function, which will send one way into this contract and this self-destruct this contract and send one way into this particular contract. So we can run Brownie, run deploy false. Wait, what's this? Transfer value, wait, where's this from? Send transfer, wait, let me fix this, I'll be right back. Okay, I actually found out what this reason is. Basically, is something related to my example, which I will further elaborate later, and I fix it. So let's just run our Brownie. Wait, okay, let's just wait for it. It's taking quite some time, so how's your day, guys? Let's wait for it. It's so slow. Come on. Okay, one of the reason why is this is because it's also related to my this contract, which I'm using Solidity 0.6.0, and recently I've actually just resetted my Zion virtual machine. The reason behind it is I accidentally corrupted it while playing with the OS. Oops, what's this issue now? Expected 1 but got 0. Constructor, huh? Oops, in my deploy contract, I think I've yet to put my contract instance. Okay, oops, sorry, it's outside. So we have to put these contracts because when we initialize the contract, we need to put our contract address, which I clearly forgotten it. Okay, attack force does not. Oops. Oh, again, I'm so sorry, guys. So I'm gonna pause the video and I'll resume it again. Okay, the contract has been mined. So over here you can see that the final contract is one way. So we forcefully send one way into our contract force. So over here we can submit our instance and we should be able to successfully complete this challenge. Okay, I'm gonna pause the video and wait for the transaction and block to be mined. Okay, the transaction has been mined and we have successfully completed this challenge. Now, let's go back to our example.so. So basically, this contract is from mastering Ethereum and from GitHub. So what this contract does is that I'm gonna explain how this vulnerability affect real world situation. So over here, you can see that user pay 0.5 ether to play with this particular function. So if the hacker forcefully send maybe 0.1 ether, this will make this if else statement to never ever be true. So you can see that this will never become milestone 1, payout 1, this will never become payout milestone 2, and this will also never be 10 ether as well. And if the attacker actually send maybe 10 ether, this contract basically will you are unable to claim the reward, and the reward will be locked forever in this contract. Is because that this the balance of this smart contract is not 10 ether but more than that, hence locking this contract and you are unable to get the reward. Hello auditors, if you love my tutorial of Force Ethernaut Challenge, please hit the subscribe button and drop a like button. Thank you for watching and have a nice day.